Hello everyone and welcome to today's video in which we will be looking at the process of hematopoiesis, or more commonly known as a production of blood cells. You have the pleasure today of seeing my beautiful handwriting in full display, and also I have spared no expenses when it comes to animations and graphics. So let's dive right into it. When we look at blood films of the peripheral blood or bone marrows, the most common immature cell that we see is the blast cell. Blast cells come in different forms and flavors. So the first type is the myeloblast. The myeloblast goes on to form the granulocytes. So that's your neutrophils, your eosinophils, and your basophils. The neutrophils are the body's first line of defense against infection. Eosinophils target parasites and allergic reactions, while basophils trigger inflammatory responses to allergens and pathogens. So next we have the lymphoblasts. The lymphoblasts, as the name suggests, go on to form the lymphocytes. So that's your T cells and your B cells. Some of the lymphocytes then differentiate into plasma cells and produce antibodies. Next, in this stunning yellow color, we have the megakaryoplasts. The megakaryoplasts form megakaryocytes, which fragment and produce platelets. Platelets, as you know, play an integral role in blood clotting. So next we have the pronormoblast. These differentiate and form erythrocytes or red blood cells. The main function of red blood cells is to carry oxygen around the body to all the different cells. Last but not least, we have the monoblasts. The monoblasts form monocytes. These are large white blood cells that circulate in the bloodstream and differentiate into macrophages, which engulf and digest pathogens and other cellular debris. The blast cell at the top of this screen is an immature cell, whereas all of the cells mentioned at the bottom, whether it's your granulocytes, your lymphocytes, your monocytes, etc., are all mature cells. To go from the immature cell to the mature cell is a multi-step process, which for the purpose of this video I will not go into. You may have heard how the myeloblast forms the neutrophil, for example, by going through the steps of becoming a promyelocyte, a myelocyte, a metamyelocyte, etc. This process of the immature turning into mature is known as maturation. So the other important thing that's happening at this stage is differentiation. Differentiation is when a unspecialized cell, such as your blast cell, which doesn't really have a function apart from making other cells, is transformed into a specialized cell, such as your red cells or erythrocytes, which carry oxygen. And the way I like to remember this is that differentiation produces cells which are different to the parent cell. But this is not where the process of hematopoiesis starts. It starts with the multipotent stem cell. A multipotent stem cell has two main properties. The first one is that it is able to self-renew or make copies of itself. The other property of multipotent stem cells is their versatility, in that they can develop into a limited range of specialized cells within a specific organ or tissue. So that explains what a multipotent stem cell is. Given these multipotent stem cells give rise to blood cells, these are also known as hematopoietic stem cells. The process by which a stem cell becomes a red cell, a platelet, or a plasma cell, for example, is not something that happens quickly. Like I mentioned before, this is a summary, and so I've left out many of the steps in between. When a stem cell divides, it does so into two cells, which then become 4, and then 8, 16, 32, and so on and so forth. The stem cell divides into two very similar looking cells, one of which is an identical copy of the stem cell, and this then goes for a nap. Who doesn't like a good nap? It goes to sleep and is available if there are any issues with the bone marrow, at which point it is reactivated and forms other cells. So while one cell chooses to go to sleep straight away, the other cell chooses a life of commitment. After undergoing various steps, it becomes committed either to the myeloid lineage or the lymphoid lineage. The common lymphoid progenitor will go on to form your dendritic cells, your Bs and T cells, and your natural killer cells, whereas the myeloid progenitor will form your monoblasts and then your monocytes, your neutrophils, eosinophils, basophils, erythrocytes, so that's your red cells, and also eventually your platelets as well. So it goes without saying that once a cell commits either to being a myeloid progenitor cell or a lymphoid progenitor cell, it won't go on to form cells from the other lineage. So a myeloid cell may go on to form your neutrophils, your red cells, your basophils, for example, but it won't ever form a lymphocyte or a dendritic cell. Vice versa, a lymphoid progenitor cell may form your Bs and T cells or your natural killer cells, but they'll never form platelets. Okay, so if we zoom out a little bit and look at the whole process from beginning to end, what you'll see is that it starts off with one stem cell at the top of the screen. And this one stem cell becomes millions and millions of mature cells through the process of maturation and differentiation. The stem cell is immature and it becomes the mature cells through what is known as proliferation. The cell proliferates. So that's another term for you to remember. So we've spoken about maturation, differentiation, and now this is proliferation. So in summary, the hematopoietic stem cell undergoes a number of differentiation and maturation steps to go from the immature to the mature. It also undergoes countless divisions, forming the millions of blood cells from that single stem cell. This is proliferation. Thank you very much for watching. If you found this video useful and informative, please do give it a thumbs up. And if you'd like to be kept up to date on new uploads, please do consider subscribing.